I'm Bob Fornal with a company here in the Columbus area called Leading Edge. I've got a slide on that here after this one real quick. This talk literally came out of a conversation. There have been several of them, but there was one recently where I was talking with 6 other developers, most of them senior developers. And I don't know how it fell out, but this side of the room hated TypeScript, and this side of the room loved TypeScript, and we were just going back and forth, and I'm kind of in the middle, right? I've learned TypeScript out of necessity. I've learned some good patterns along the way. I'm kind of weird in that I collect code snippets here and there. I mean, I've got hundreds of them. And after this talk, I went back and looked, and I had 48 really good ones at it that I find I use regularly with teams, often at the enterprise level. And so I put it together in this talk. It was actually my first time with Copilot running on my editor at the time, and it really streamlined helping getting my talk put together. It didn't write any of the content. It helped organize things in a way I didn't expect, and it was really kind of cool. Saw some patterns that I didn't expect. Now realize I said 48 code snippets, and if I were to show you 48 code snippets and talk about each snippet, we're going to be here for about 3 hours. I'm not planning on being here that long. If I'm walking too far, yell at me, all right? I know he's got a camera over there. I'm trying to not to move too much, getting out of my camera range. And so my next phase was to take a look at how I streamlined that down a little bit, and I did. And I think we got this down to 36 slides, which I think is pretty reasonable for the time frame we have, okay? All right, so my company, Leading Edge, we believe technology is a powerful tool. It transforms business, unlocks potential. As strategists, innovators, partners, we don't just solve problems, we craft solutions that positively disrupt your business. I love that, positively disrupt, right? It's about change, it's about growth and that kind of thing. So TypeScript you might like, I think fits into this really well, okay? We've all been there, okay? Love this, the ongoing horror show. TypeScript error messages. And this is actually sample code, but it's things I've seen before where you get this class within TypeScript that is just massive. And you get that error and it's like, how did I even get here that I have to go that deep into what's going on? It's brutal, and sometimes you get them circular too. That's always kind of fun when this happens. And yes, that's me up there. I hand drew that. My great artwork. I'm not going to lean on AI to do my images for this, okay? Oh, so what are we going to cover? I don't have notes on what we're going to cover, so I'm going to turn around. So sorry, you're going to see my head up there. We're going to cover some type philosophy, patterns that prevent bugs, features that you're probably overlooking, keeping types manageable. That's a good one. Real-world patterns with TypeScript, practical tips and tricks, common pitfalls to avoid, and adopting strategy. And yes, you could probably read the slide, but I read that one out for us. Okay, we're going to cover all of those, hopefully, in the next 40 minutes. So, stop fighting inferences. Okay, in this case, we have some JavaScript here. It doesn't look too, or TypeScript doesn't look too horrible, right? We got a username with a string, it's Alice, we got account number 42. Items. Now, I left this one in, an items array. I left this one in, and I meant to take it out, but I think it's good to actually have it in. Modern linters actually will recommend against this pattern that you're seeing right here. Okay, these are really simple. It's easy to look at username equals Alice. Let's take a look at the correct code. Here we go. It's really easy to identify that Alice is a string. It's a constant, so it's not going to change, right? It's easy to identify that count is a number and that items is an array of string. Okay? Now, that third pattern, it assumes the array of string, and it will recommend if you try to put a number in there, it says, hey, we've assumed it is. TypeScript will pop that up if you're trying to put something in there that it doesn't expect on that assumption. Okay? So the typing actually will tell you to turn that off. So here, this is boundaries, okay? Types when it matters. We have a function up there formatting user, username. We have this big object on what the user is. We have string out there that's being returned, and it returns a string. Okay, that's pretty cool, nothing complicated. Okay, we have that API interface up there showing the data and the error on the API response. These are just different types of where putting the type in where it matters. Okay? When you're looking at the user coming in, yes, it's good to know what's coming in on the user. Do we have to define it that way? Okay, we could define a type before that or an interface to pass in to make that a little cleaner, knowing that it's a string that comes out. That's an important piece, right? When you're defining an API response, now, this I kind of agree with and I disagree with at some point. I've used this one a few times. API responses is where I struggled the most, okay? When I first started using TypeScript, I was there when TypeScript was introduced, and I was a skeptic, as many people were. I wrote these big, beautiful, monolithic things, knowing this is what was coming from the back end, because we had talked about it. He sat right next to me. All right? And next week it changed. And the week after that it changed again. And the week after that it changed. I was spending more time maintaining this big monster object than I was actually writing code in some instances. Okay? What I've come to realize is sometimes you do need to streamline that, but type when it does matter, okay? Now, any is one of those ones that always comes up. It's your escape hatch, right? You don't know what to put any, okay? And every TypeScript talk you go to, they're going to say don't use any. Use unknown, okay? So here we've got that parsed JSON. Something's coming out. We don't want to define what it is because it's going to change based on what's being sent in. And in this case where we do that doesn't cause a runtime error, you know, when it doesn't error on compile. Okay, if we shift this one, I like this, we're shifting it to unknown. Okay, and we have to check that data coming out, that it's an object, that it's not null, that it has the key name somewhere within the data. We do that type checking in there. Now we know we safely can use that object. So that an unknown allows us to put that check protection in place. It gives us a way to put the protection in place, okay, without using any. Now, I will admit, I use any once in a while, okay? We all do it, okay? Just enough types. Type when it matters, and the unknown safety net. These are the simple ones, right? We're digging into heavier ones here soon. Bug patterns. Bug pattern prevention, okay? Discriminated unions here. Ooh, I got lots of code to look at here. All right, so we have an interface with a response, success, data, error, basic one, nothing complicated there. We're handling a response, passing in that response. If it's success, it works, okay? Still could be undefined. All right, I have actually seen that come through as an undefined. So let's take a look at how to shift this one slightly. To make this right, we have the status of success, data, the error. So when we check success, we can actually check for that state, okay? Which gives us a chance to handle that error as it comes through. All right, it's not a big shift in how we define it, but it gives you a lot better resiliency in your application. Here's a better example. Right? So I can have a status of idle, loading, success, error. These are things we normally have in our applications, right? And then under our user profile, we have a way to take that state and do something with it, right? We're returning a click to load, we're returning a spinner, or we're returning data. We're returning an error message, okay? This is a much more practical example. This is one that I pull out of my toolkit on a regular basis to make sure we're doing things right, because that or in the typing of our load state is one that I don't remember off the top of my head most times in terms of writing it. So I just go back to my collection of files and I pull this one out. Literal types, better than enums. Okay, so here we got a function set theme. We're passing in a theme string. We got a document by class name equals theme being assigned. Okay, and we're setting the theme to dark. Now in this case, we set it to dark with 2 Ks. It doesn't error. We're trying to set a dark mode, right? So there we're changing a class to theme our page. okay? Shift this slightly, and we end up with something like this. We have a type theme that has one of three possible states, okay? We're passing in theme, which is now typed, and assigning, okay? So in our first state there, where we do dark with 2 Ks, we immediately get an error before we ever run our code. It's not going to let you do it, okay? Let's take a look at the next iteration using this one in a little more real-world scenario. HTTP method. I have 4. Occasionally there are more. We all know that. We can add to the list. It's not complicated, right? We have a request config over here that uses that HTTP method, an endpoint that we're accessing. So in our config, we set our method, we set our endpoint. Notice that second one down there, 13 to 17, where it has a get s. You get that error in your editor before it compiles, before you ever run the code. You got a chance to fix it. We all make typos. I know I do, okay? And again, this is one I'll go back to and reference once in a while. Okay, so read-only, powerful tool for immutability. Arrays and objects are the complicated one, right? We create a const with an object, with an array. You can still add to those, okay? It makes intent clear to other developers, but it's got room for mistakes to be made, okay? We got the code sample here. It is kind of a sneaky one. You've had some time to look at it, so let's go take a look at how to correct this one, right? So we're creating a function to process the items. We've got a read-only string array coming in. We're passing out an array of strings, and we're just sorting it. Nothing complicated there. We've got a config interface with an API key and timeout that are read-only. We're not using the const in this particular case. Okay, and in our config, which we typed with that interface, we've got API key secret and timeout, and that's fine. But if we try and change API key to something it doesn't expect, it gives us an error that we can't mutate it. Okay, just a little better way to look at that mutation. So a couple quick things we covered here: discriminated unions, literal types, and then the read-only that you can use within there that I think a lot of people miss. I do. I go back and reference my notes all the time. That's why we have a talk today. So here we're going to jump into template literal types. I like template literal types. And seeing these as a safe route pattern is one that really caught me a couple years back. It was an interesting adaptation. So we got a navigate route. We have that route defined up there. Notice it's 2 template strings, 3. 3 template strings, 3 options, right? And we assign window location to that href, so it routes you that direction. This is simple, plain JavaScript at this point, well, TypeScript, but really JavaScript mutation to change your address. And we do this navigate. And the first 2 are fine because they meet those template string patterns. The third one, because it doesn't meet one of those patterns, it fails on us immediately. Doesn't let it occur. So if you entered that code in the editor, again, before compile time, before runtime, you get the error message. This one I think is pretty cool. If you've got a lot of routes, it takes a little time to put them in, but I tend to build that list over time. I kind of like that one. All right, we skipped one of the ones, now we're at 3.3. Okay, I'll talk about that in a second. Type-safe objects, here we go. What do we have? We have satisfies the operator type-safe objects, right? So in this old dilemma, we have a config, we have a record that's defined there, right? A key and a value. We config the endpoint, we have a URL that we're building up here. We have a config down below with another endpoint, and config endpoint allows you to enter that way. There's no error that populates, okay? To fix this, all right, as we look at this, we've created the config, nothing complicated there. We actually created the config type. We're creating the config down below, but it satisfies that type. Okay, a little different in assignment on that one. But notice config endpoint to uppercase, we can do that. It's a string. The config timeout to a fixed value, we can do that because that's a number. But we can't enter config.endpoint by itself becomes a typo, okay, because of the type safety. Real world use case, I think, is where this one really stands out. If you look at that third one down there on line, or the second one down there, line 11, that oops path, we have the routes home, H-O-E-M spelled wrong with the path. It catches that typo that the previous one would not have caught. Okay. It's an interesting type safety layer there. Now, I did skip a few. Okay, and this brings up one small thing I'll bring up at the end. At the end of this, there's a QR code. The QR code will bring up my entire slide deck PDF. I've reworked it. It's a straight text document. It has all of the slides, all of the codes, all of my notes, and it is long because even the ones that are crossed out here that we skip are going to be in there. Okay, it's like a 36 or 38 page document. It's huge. I want to make sure you get everything, even the ones I skipped. Okay, so yes, you screenshot if you want. Love that, but you're going to get all this separately. All right, so deriving types with omit, partial, and pick. All right, this was an interesting one. This is one I absolutely go back to every time because I tend to get it wrong if I try and write it myself. But in this case, we're creating a user request, name, email, age, nothing complicated there in that interface. Second interface, we're doing an updated user request, and it's got the same data in it. Okay, name, email, name, email, age. So it's exactly the same information. It's duplicate. Okay, to do this one right, an easier pattern, you've got a more defined user here. We're going to create a user request, but we're going to, on user, we're going to omit ID and create it at. We're going to do another type, which is the updated user request partial of the create user request. Okay, and then we can create a user response, picking from user ID, name, and email. This allows us to take that original interface and use the pieces of it we need, as opposed to rewriting a whole new element with those pieces in there. Dry, right? Don't repeat yourself. Okay, let code generate types, type of, key of. Okay, so here we got a basic API endpoint. We've seen lots of those so far, defined as constant. And then we've got a type endpoint, key of, type of API endpoints. We've got a type endpoint path, blah, blah, blah. We've got a function fetch data, endpoint. I can't believe I just did blah, blah, blah in the middle of that, where we're fetching API endpoint. Okay, fetch data users works fine. Fetch data users with two S's is going to fail. Okay, it's not going to fail there. It's going to fail when you run your code with that undefined. And then you're going to come back in and trace down that misspell. Okay, to do this cleanly, okay, I'm doing this with an event handler. It's one of the trickier ones I've dealt with over the years, where we handle click, key press, and scroll. We're creating an event type, key of, type of, event handler, handlers, and then an event handler that extends the event type with a type of event handler of T. Okay, in our function, we're adding the listener, extending that event type. Okay, and then our type and our handler within that. All your implementation goes inside that, and you have that add event handler. Okay, it's a much cleaner way of handling that generation. Okay, so here, again, these are the two we covered, the drive types. Really like that one. Then the let code generate with types. I don't use that one quite as often, but it fits in this section reasonably well. Okay. So, type-safe event emitters. We're using generic map types to create type-safe event emitters. Let's see what we have here. So we have an emitter on, user created, with a function data passed in, console log. So it's not really doing much, right? When a user's created, it console logs the name. And we emit the user created user. But notice created is spelled wrong. In your TypeScript, in your editor, there's no error. Runtime, that's not going to work. Okay. What we need to do here is a little bigger. It's a good thing that this can scroll on. It's going to be interesting sliding over there. But we're creating an interface. An interface events up there with user created, user deleted, post published, all the object data on those. We have a typed emitter out here, okay? That takes in the event and the handler, and it's defining that handler data being passed in as events that we have up above our interface, okay? Type void, you add your implementation in there, and you've got an emit object in there as well, or emit component in there as well, with its implementation. So our emitter, when we new it up, and I got to get my mouse over there to scroll. There we go. Perfect. So we new up our emitter, And then the emitter on, we can pass in the created, we can tell it the console log at that time it works. Autocomplete picks that up. That second emitter, that emitter we say down there, emitter emit, is going to fail. Created is not spelled right. Got it. Typo caught. Okay, but if we look at the other user created, let's try this real quick. I'm going to come back up here and let's minimize this one down. It should let me. There we go. There we go. So we can see our created up above. Created has not just an ID, but a name. So you're going to get a typo error there because it doesn't have part of what it needs. Okay, type safe event emitters. If you're a front-end developer like I am, those are stunningly useful. So here, builder pattern with type states. Oh, this is a fun one. We've got the server config, right? Host, port, API key. I build these out every once in a while. Type config builder, okay, that extends the partial server config. We're setting host, port, set build API key, and build, right? So we're extending. And then in our create config builder, we're using a partial server config coming in. And then we have that state out there, the config builder, and it's running off the screen. I don't think there's a lot out there off the screen, but let me see if we can see that real quick. There's my horizontal scroll bar. Yeah, we're not missing much out on the end of that one. Okay, where we return our set host, set port, set API key, set build with the full functionality. Okay, there's a much cleaner way to do it. Your system will remember those type states. This is a pattern that I pull in every now and then on particular projects, especially the larger ones, where there can be some ambiguity in accessing the API endpoints. We want to make sure we standardize that. Type safe dependency injection. Front end, right? Angular, React, Vue. Injection is dependency injection is one of those big things we do on all the time. Okay, so here we've got just an example. These are things I pull in. Interfaces for a logger, right? Not complicated. It's logging whatever the message is. We've got an interface for a database, for a query, SQL query in this case. Services, logger, and database. We have container type safety down below that I'm going to have to scroll for. I forgot I had to scroll this much. I should have separated those. Okay, so the container with the private services, the new mapped up services, a way to register, a way to get. Nothing real complicated in there, but typed well. Okay, and then usage of those, where we have the container newed up, we have the container registered logger, and the console logger. Because database is spelled wrong, we immediately get that typo, okay, in editor. We're using that container to get logger, and that works fine. But if we do a logger log of hello, it actually does work because it's typed well. It's typed correctly, okay? Let me tell you, reading code and explaining it all at the same time is a lot of fun. So we covered type safety event emitters, we covered builder patterns with type state, we covered the dependency injection with type safety. All right, getting there, guys. We are past the halfway point. So, switch checks. Okay, using discriminated unions and the never type. Okay, first time I came across a never, it was a weird one to kind of figure out what's going on, but it ensures all the cases are handled within our switch statement. Okay, so in this case we have a status pending, approved, and rejected. We're handling a status. We're switching on the status, right? So if it's pending, we're pending. If it's approved, it's approved. If it's rejected, rejected. And we've got a default down there that does an exhaustive typed never with status. Okay, which then after that throws the error under status, and it passes in that exhaustive and ensures that we get things correctly handled, right? So if we add a new status, that line 19, we change our status type, we're going to get an error because we don't have it handled. Okay, it's going to pass to the default because that case doesn't exist in that switch statement. I mean, that's an important piece. People change their code all the time. This ensures that change doesn't break things. Okay, it's kind of a cool one, I think. The never is still kind of a strange one to me at times. type predicates for array filtering. Okay, so in this case we have an array of values, and these are weird values, right? We have undefineds, we have nulls, we have strings, all through it, filtered. Okay, and just saying not equals null. Right, but you're going to get the strings, the nulls, and the undefined still come through. Okay, that's how it's typed because that's what the original array is. Okay, well, if we use a type predicates is not null, where we're setting our value as a value or a null or an undefined, and then return not equal to null. At that point, what comes back is an array of string. Since we didn't assign on either of those, make sure it's array of string down there at the bottom. It's an interesting use case for cleaning up a filter. I have run into that now and then. So, section 6 here, we've covered the exhaustive switch checks, discriminated unions with the never. We talked about the array filtering. There are two we didn't cover, and they are in the notes that you can capture at the end if you want on extended types to prevent mixing similar types and assert functions. They're type guards. That's a pretty cool one. But given my amount of time, I've really got to streamline down a little bit, and we're getting towards the end because I have a total of 8 sections and we're on 7. So here, do not abuse generics. Okay, all been guilty of that if you've written any TypeScript. Okay, here we have an over-engineered function, get value. It extends, and we got an extends, and we've got an object of t coming in and a key of t coming in, returning v, and it returns an object. To be fair, today I'd probably throw it into Copilot and say, what the heck are we trying to do here? Right? I mean, I write practical TypeScript. Right? I don't need to be an expert necessarily in all this. This is one that I probably would ask for a little bit of help. But let's take this to a cleaner way of doing it. We need to get a value, right? Didn't change that too much there, what's coming in, but we're just returning an object. So key, right? Objects defined up there, keys defined up there. Easy enough. If you don't need to make it complicated, don't. Okay? I see it all the time where it's so complicated, you guys spend more time figuring out what's going on. It's not about figuring out what's going on. It's about helping that next developer understand the code. So you've got to write TypeScript that they can understand. So here, avoid type assertions unless they're necessary, okay? This is one that's interesting, right? We've got the data, we're getting an API response as a user, and really strange things happen here at times. These errors, an error in here causes problems, right? The type assertion as, in many cases when I see it, I double check because it can be a design problem. We need to improve our types for safe narrowing. This doesn't narrow it down well enough. What we need to do is more along these lines, right? We've got an isUser function that we built here. Data type is unknown. We're returning the data isUser, not as. Okay, we're returning a type of data, verifying that it is an object, and it's not null, and it has an ID, and it has an email. In this case, I know, because I've made it type safe, that is a user, so the return data object is a user. Okay, so we can say if isUser API response, we console log it. We know it's safe. It's a little longer, but it's protective in that particular case. Okay. I like this one. Don't fight the compiler. I fight the compiler all the time. Okay. The any escape hatch. Right? We talk about this all the time. Okay. When I see the any, my next question is, why is it hard? Right? What it normally means is your types don't match. Right? You're deep in the code after the responses come back. You're looking at something else on a filter or a sort or something like this, and you're looking at it and you're going, okay, I want to do a dot whatever because I know it's in the data because I saw it in the network tab when I'm seeing the code come in, but you're telling me it doesn't exist on the object, on the type. Right? Don't fight the compiler. Give it the flexibility to get that. Be careful of that any on that fighting of the compiler. Now on section 7, I didn't drop anything. Don't abuse generics. Avoid type assertions. Don't fight the compiler. Okay. All right, here we go. Start small. Incremental adoption. Okay. One of the questions I get all the time is, we don't have TypeScript in this project. I was actually talking to somebody today about one of the applications that I built out for their organization. And I built that out 9 years ago with Leading Edge. For my edgers in the room, very first project I work on. It was a scripting language. It's pure JavaScript. It is, counting the tests, it's something like 80,000 lines of code. Okay, it's a language, script language. There's zero TypeScript because TypeScript wasn't there to put it in at the time. Okay, it's got layer upon layer upon layer of unit tests, so it's solid. And they're integrating it into the new one, and last I heard, they haven't changed a line of it yet. Now, if I were on that project, I'd be tempted to put TypeScript into it at this point, but I would start incrementally, right? I'm not going to build these big, massive objects and throw it in there and watch code down the road, watch tests down the road start to crash where I've got to work on it, right? You take things and take it small, right? We allow JavaScript, we allow check.js, we allow strict in our tsconfig. Turn that to false. Let things be loose initially. Tighten them up as you've added into the project, right? It's not a let's stop and put TypeScript into a 10,000 line project or a 100,000 line project or a 200,000 line project. It's, hey, let's make the code a little better than we left it, right? Boy Scout rule way back in the day, right? You know, you go out there, you clean up your trash, and if you see other trash, you pick it up too. You do the right thing, right? Start small, build it out small. Convert one file at a time. If it's a big file, maybe you convert one function within that file, one object within a file, whatever, right? Gradually enable those stricter checks, okay? Probably the best advice I'll give you in there is do it small if it's adoption. The next one in here is probably another one of the major important ones, which is the 80-20 rule, right? We focus on high value areas first. Where do we get the most value in adding TypeScript? Right? API boundaries, request responses. I'm not saying build big giant objects that are going to clog up the rest of your code. Build it out in such a way that you know what to expect. But allow a little bit of variance in there with API boundaries because things change, right? Shared utility functions, state management, configuration objects, right? These are high value points that you touch on with the TypeScript that you use to ensure you're getting your most impact. Okay, in my mind, the ones to skip for now are the little one-off scripts, something that's been thrown in. You know it's a patch, you know it's going to get integrated into the code later in a better way. Why spend time there? Legacy code that you rarely touch. Okay, a scripting language would be one of those benefits in there, right? I wrote this thing. It's a ton of code, and it works. Why spend the money and the time to add TypeScript in there when you know it's solid? Okay? And when I talk solid, I'm not just talking I know this code runs well. I'm talking I was there for another year after that code was implemented into production. I was there to know that we got 3 bug reports in that first year. We're talking hundreds of companies across the globe using it. There was one lady in Sweden or something like that that had 6 computers in her house that every morning she'd get up and she'd run these audit reports, and it's running this script. And it would run 8 hours before she got her data at the end of the day. Okay, so this script got hammered hard. Now, of those 3 errors, 2 of those were missed requirements. Somebody didn't tell me that the variables weren't 11 characters in length, they were actually 25. Okay, it's a configuration option. That took me about 3 seconds to change. I don't remember what the second one was. There was actually 1 bug in the code reported in a year of end user use. Okay, if the code is legacy code and it works, why waste the time there? Spend the time in these other high priority areas. Overtyped function, utility functions, utility. Okay, utility functions are the ones you call and you reference once in a while, you don't use deeply. Don't spend time there. Don't waste the time fixing the TypeScript in there if it's utility, okay? At least early, for now. I mean, these are things you can come back to and determine where to improve. As you're writing that TypeScript, let's go to the summary on this one. I always keep in mind when I'm working on the TypeScript is I'm not writing TypeScript to define the objects. I'm not writing TypeScript to define the data and how it goes through. What I'm thinking about is, how do I type this so that as that data passes through the application, I get proper checks and balances? I need the right checks and balances, right? I'm looking at critical paths. I'm looking at important areas within the application. I'm looking at where can I get the most impact in putting the typing in. Any doesn't help. All it does is let data pass through without any kind of protection. May as well not put it in instead of putting the any in. Okay? You're better off not putting it in. Okay? Because the any is easy to skip over. It's easy to have things get messed up in there. Okay? Getting close. Quick wins you can apply today. All right, I'm going to look at the code in a second. Literal types for constants. Read only for immutability. Satisfies for safe configuration. Type predicates for filtering, exhaustive checks. We've talked about most of these. Right? These are easy, early, quick wins. Okay? For at least a minimal level of protection. Start small, like I said. Don't beat it up and put a ton of stuff in there that then starts to break things and you got to go back and fix things. Start small, make sure it's working. Take the next one, start small, make sure it's working. Okay? Move forward. Types and boundaries, infer in the middle, make invalid states unrepresentable, discrimination unions, derive types from a single source, right? The dry principle we talked about. Use unknown, not any. TypeScript is a tool, okay? This is important here. That last one is probably the most important in my mind. TypeScript is a tool. It's not a test of purity. The idea isn't to build these super complex types. The idea is to make your code safe, to make your code easy to reason about and understand. Okay? And I think that's what a lot of people miss in here. Now, resources. Yeah, I got a list of resources here, right? The official TypeScript, the TypeScript playground. I love the playground. TypeScript community, total types, type challenges. The type challenges are fun. It hurts my brain some days, but they are fun, okay? Perfect types don't exist. Better types do. Don't go for perfection. Go for improvement, okay? Start where you are. Use what helps. Skip what doesn't. If it's not helping, leave it alone, okay? Put your effort where it makes sense. So, we have time for questions, I think. Not a lot. QR code takes you to the big, long version of my presentation. Like I said, it's just a text file. It has all the content, all the code, extra code. There's code I use to test some of these things because I'm looking at it going, does that really work? So I actually added the tests in there as well. And my notes that I was reading off, which I found out a couple of my slides don't have much in the way of notes and should have more. Okay, which, sorry, I had to turn my back to you guys a few times. So, TypeScript you might like. Yeah, that's what I got, guys. Thanks for coming.